Okay, hi everybody. We'll be talking about SPSS session 5 for this Friday today. And you can locate the session 5 material under our course Intro Stats for this week, October the 26th to November the 1st, SPSS session 5 folder. Of course, this is done over the virtual desktop that we are currently in. Okay, so make sure you log into the virtual desktop first of all, okay, and then go to My Courses, open the SPSS session 5 folder. Once you get into this folder, you'll see two files. One is the two sample t-test, which is the work file that we've been doing. Okay, so make sure you do the work in this file and then upload the same file into the My Courses for grading. And there is another file inside of this folder, which is session 5 data.siv. If you click open this file, you'll be seeing the variable view gives you 6 variables: EDUC, region, child's age, kid born, gender 1, HRS 2, okay, hours 2, and these are the data view. So we'll be basically using these two materials in order to complete our session 5. So the session 5 is focusing on comparing two different means. Okay, that means we're trying to compare the two sample and compare their means. And the basic function you need to use for the SPSS is for two sample t-tests, you gotta go these steps. And we will also talk about one important skill and technique you need to do for recoding the variables in SPSS. So let's get it started. So first of all, question 1, open session 5 data.siv and locate the variables region, child's age, kid born, gender 1, hours 2, and education. Describe each of these variables and labels. Okay, so we're just going to very briefly look at these 6 variables. So education, EDUC, its labels is highest year of school completed, and its values basically looks like, if you go back to the education, you can click this one. The values go from single digit to 2-digit values, right? Okay. Let's talk about the highest year of school completed. Now, second is region. So region means the region of the interview. Okay. If you look at the values in its label, okay, so 0 means not assigned. 1 is in New England region, to Middle Atlantic, and so forth. 9 is Pacific. So there are basically 9 regions to be discussed. Okay. Child's means number of children, right? And that's a quantitative variable for child's. You can see the value as we have seen before. Okay, we can also construct the descriptive stats for this child's, like their mean and standard deviation. I think we've done that in one of the SPSS session. Age kid born is R's age when first child born. You guys have seen this variable a few times as well. Number 5, gender 1, gender of the first person. Okay, so if you keep reading its values, you can see 1 means male, 2 means female. Okay. And 8 means don't know, and 9 is not applicable. HRS2, it means number of hours usually work a week. This is talking about the hours of work per week. The values are typically quantitative. If you look at HRS, okay, it goes from 30, 40, and there are other values as well. Okay. The negative one is IAP. So RAP, as we mentioned before, IAP means inapplicable, and NA means no answer. Okay, so if you see -1, it means this is inapplicable to this respondent. Number of hours usually work a week. All right, so those are the 5 variables, 6 variables. Okay, now keep going. Let's look at the question 2. At the 5% level of significance, test whether female and a male work the same number of hours per week. Okay, so this is trying to check 2 groups of people, right? They're trying to compare the female, okay, so female with male, okay, female with male, and they're trying to compare if the female and a male would work the same number of hours per week for their means. Okay, so this is Again, compare two groups. Clear the annotation here. So in terms of the null and alternative, we can look at the group 1 and 2, female and a male. By the way, for the female and a male, it's related to the variable. The variable we're using here would be gender 1, which is related to the female and a male. And for the gender 1, let's see which one is female, which one is male. So male is number 1, female is 2. Okay. So 1 equals male and 2 equals female. Okay. So we can just use this as group 1 and a group 2. Okay. So null hypothesis here would just be they have the same number of hours, right? So mu1 equals mu2. Okay. So let's see, mu1 equals mu2. Okay, you can put this as summary, a subscript, lowercase. And alternative, because it doesn't say which one is bigger. Okay, so alternative would just be mu1 is different from mu2. I'm just gonna copy this, paste and copy and paste and just add it over here. So alternative would be mu1 is different from mu2 because we don't know which one is higher, or we're trying to we're not trying to test a claim which one is higher than the other one, right? So this will be a two-tailed test. Two-tailed test. And the quantity we're comparing is the number of hours they work. So the variable, not only we're using gender 1, but also we are also using HRS2, okay, which is talking about the hours worked per week. Identify the test. Okay, so this is two groups, right? And 2 sample. And these 2 samples are, one is female, one is male, so they're independent samples. 2 independent samples. So we should be going 2 sample t-test, right? 2 sample t-test. And we're not assuming they have the same standard deviation. So assume the 2 populations don't have the same population standard deviation, which is the one that we did in calculator node pool situation, right? So 2 independent samples and not assuming the same population standard deviations. Okay, so let's carry out the 2 sample t-test for these 2 variables. We are comparing ours, okay, and with the criteria of gender, putting them into groups. So go ahead, let's get into SPSS. First of all, we gotta go analyze, compare means. Okay, check over here, independent samples t-test. Okay, so independent sample t-test. We're testing on the number of hours they work per week. So the number of hours, move over here as the test variable. Okay, if you want to see the entire name for the variable, you can drag this to the right. We need to enter the grouping variable. Grouping variable means how do we put the groups? So groups are simply classified by the gender, right? Okay, so the gender of the first person. So gender is a grouping variable. Define groups. Okay, so group 1 is our, according to what we said, group 1 would be male. Okay, male is using the label 1 and the gender. So we're just going to type 1 because 1 in gender represents male. Group 2 will be the value 2, which represents female. Okay, continue. Options, if you're interested in knowing the confidence interval of the difference of the two means, you can click the option. It's not necessary, but I think it, let's see. So go ahead and click OK. All right, there we go. So we've got these two output tables. The first table describes the statistics of these two groups, like male, the number of hours they usually work will be 37.07. Female, the number of hours they would work will be 39.15. 39.15. All right, so that's going to be the first group. Let's copy and then paste back into our file. That's the output. And then there's also about our T. Okay, let's also copy the second table, independent sample t-test. Okay, so copy and paste. All right, so once again, if your table is out of its, the format is not very good, what you can do is, let's see, choose this table. Okay, click this button for choosing the table and right click. You can see auto fit to window. Okay, that can make it smaller and the width will be adjusted automatically. Okay, now my table has been split into 2 parts over 2 pages. I'm going to move them into the same page. All right, so this is the independent sample test table, which is for the t-test. What we need to do is we are not assuming equal variances or standard deviations. So we should be looking at the second part. Equal variances not assumed. Okay. And let's check the T. The T statistic T is given as this amount, negative 0.621 with the degrees of freedom 52.991. And this is the p-value. P-value is 0.537. The mean difference is talking about the sample differences, right? So this one, if we explain it, this is talking about X bar, the difference between those two sample means. So the sample mean hours worked for the males, subtract sample mean number of hours, mean number of hours worked by the females. Okay, so X1 bar minus X2 bar. That's what I meant over there. Okay, let's go ahead and continue our work. Let's put the test statistic. So test statistic is T with degrees of freedom 52.991. Its value is negative 0.621. P-value here is pointed out by the significance. Over here, two-tailed 0.537. Well, this is already two-tailed test. For two-tailed test. Okay, therefore we don't have to divide this by 2 because the test itself is two-tailed. If it's one-tailed, you need to divide that by 2. All right, so that's your test statistic and p-value. And then we can make our decision, right? So decision depends on your alpha. So alpha is 5%, 0.05. So over here, alpha equals to 0.05. I'm going to use that alpha again. So alpha equals to 0.05. Therefore, p-value is greater than this alpha, right? Higher than the alpha. P is high, null will fly. So we failed to reject null hypothesis. Okay, fail to reject null, which means the same as fail to accept alternative. So we don't have enough evidence to accept the alternative based on this given sample. Okay, last step, summarize your conclusion. So we are, there's not, over here, so there is not, right, because you failed to. So there is not sufficient evidence to claim that at alpha equals to 0.05 at 5% level, that the meaning of alternative, right? The meaning of alternative is mu1 different from mu2, which means male and a female work the different number of hours per week. Work that male and female work different numbers of hours per week. Okay, and here p-value is 0.537. So we don't have enough evidence to claim that the male and female have different number of hours worked per week. Okay, you can claim that they work different hours. All right, so that is question 1. This is to compare two independent samples, right? Independent samples, we'll be doing 2 sample t-tests and not assuming the same population standard deviations or variances. Okay, so that's used a lot when you want to compare two groups. Next, we want to talk about one skill that is called recoding variables into new categories. So recoding. Now, recoding is used a lot. We are going to give one example. So we want to recode the variable region. If you have forgot about a region, okay, so region has these different 9 and 10 labels. 0 means not assigned, and 1 New England, and 9 means Pacific region in US. So we want to recode the region. Okay, this is the old variable region. I want to just put it into 2 groups. I want to put them into just South or not. Either count the region as South region or not South region. So value 1 represents South, and value 0 represents not South. Okay. So that means instead of putting 9 different regions, I'm just going to change that into 2 different regions. One is not South, one is South. Okay, so identify the South and not South. The goal is to compare some characteristics between the region in the South and the region that's not in South. So over here, we have put over here. So 0, not assigned. This is considered to be not South. New England is not South, so the value will be 0. Middle Atlantic will be not South. East, North, Central will be not South, the value will be 0. And West, North, Central, not South, the value will be 0. South Atlantic will be South. East and South Central will be South. West and South Central will be South. Mountain area typically is a majority part is not South, so we're going to do not South. Pacific, let's count it as not South, so the value will be 0. Okay, so let's try to do the recode. We want to try to generate a new variable called South or not based on the old variable region. And what we need to do is let's go back to the SPSS, and you're going to follow these steps. Transform. So go back to SPSS and go transform. There's 2 options for you: recode into same variables or recode into different variables. We want to keep the region as it is, so we want to recode into different variables. And over here, we're going to move the old variable as the input, which is the region of interview. The new variable will be called South or not. Make sure you do underline in between different words. If you take space, the SPSS is going to give you error message because SPSS does not take space as the character. So the label is okay. For the label, it's just some description for this variable. You want to tell yourself what this is about. So the label is whether the region is from south or not, right? That is the label. Label, you can put space in it. Okay, first we'll change. Click change, then you'll be doing this conversion. We also need to change their values, right? So let's look at our definition over here. For all the values from 0 to 4, the new value will be 0. Right? From 0 to 4, new value will be 0. So I can do value. From 0 to 4, the new value will be 1. Okay. Oh, sorry, the new value will be 0. Add 0 to 4, new value will be 0. All right, keep going. The next step will be 5 to 7. 5 to 7, new value is 1. 5 to 7, new value will be 1. Add. And lastly, we have 8 to 9, the new value will be 0. 8 to 9, new value will be 0. Or you can individually type in the values in this value column. So add, okay. And continue. And let's hit OK. All right, so then in the output tab, it will give you this information saying this has been executed. And let's check what happens to your SPSS data set. You see there's a new variable coming out as south or not, right? Let's check its variable view. So this new variable is called south or not with underscore. This is numeric, which will be 8. Decimal, we don't really need decimals, so let's convert that to 0. The label is whether the region is from south or not. Values, okay, let's enter value. There are two values, right? 0 and 1. So 0 means not in south. 1 means in south. Okay. So south or not south. Okay, hit OK. And over here, so we've got south or not, and we see 0 and a 1 being distributed. Okay. If you're interested, we can look at the frequency distribution of south or not to see how many actual interviews are occurring in the south region and how many interviews were occurring in the not south region. So quickly analyze the group of stats, frequencies, look at south or not, which is whether the region is from south or not. Move this over. I'm just going to quickly display the frequency table. Okay, so looks like there's 1,052 interviews occurred in South and 1,815 interviews not occurring in South. Okay, so there are two regions for us to compare. All right, keep going. The next question we want to do is, there is not South because you're going to do this. Item 4, at the 5% level of significance, we want to test whether, on average, people in South region have less years of education than people in North region. Okay, this is what we're testing. Identify the null and alternative hypothesis. So group 1 will be people in South, right? So education of people in South. Group 2 would be education of people not in South. Okay, those are the two groups following the claim. And the null hypothesis, let me copy and paste from the previous one so we can save some time. So null hypothesis will just be mu1 equals mu2, right? people in South and not in South have the same level of same years of education on average. And alternative will be different. People in the South have less years. Okay. Less years, so the value will be lower. Right. So mu1 will be less than mu2. So less than. And this is no longer two-tailed test. This is left-tailed test, right? Left-tailed test. Okay, and keep in mind that for the South or not variable. Okay, 0 means not South, and 1 means South, right? So the people in South, its value in the South or not value would be 0. People not in South, when it talks about the value and the South or not, its value will be 1 here, and the value will be 0 here. Okay, because we need to put this into the grouping later on. So grouping value, right? Grouping value will be 1. Grouping value would be 0. Okay. This is some notes that we need to take a little bit. You want to make sure you're putting the right value for the two different groups. Identify the test. Again, this will be a 2-sample t-test because South and not South, they're independent, and we're not assuming the same population mean, right? So same thing here. All right, keep going. So next we'll be looking for the test statistic and some p-value and make our decision. All right, so go back to over here and let's go analyze, compare means, independent sample t-test. Okay, this time we are comparing the highest year of school completed. The education is the test variable. We are grouping by whether the region is from South or not. So grouping variable will be South or not. Define groups. Okay, now as we just mentioned, the first group. So the first group, as we mentioned, is people in South. So grouping value will be 1, putting 1 in the value. Group 2 will be people not in South, whose value will be 0. Okay, continue, hit OK. Okay, let's check out the output. So the output here talks about the highest year of school completed. In South, the mean is 13.49. Not in South, the mean is 13.88. Looks like from the sample, the two means are very close. Copy. And paste. All right. And keep going. Let's look at the test statistic with T. So copy and paste. Okay, again, you can adjust this by clicking this table button and then do auto fit to the window. Okay, fit to the window. Somehow it's breaking my pages again. So let me put that into the next page. Alrighty. So this is independent sample t-test. And let's see. Equal variances are not assumed. And T-n difference is what we, degrees of freedom is what we are concerned. And significance level here, I mean, the p-value is obtained from the sig. Okay. So now let's go ahead and make our conclusion. So test statistics is T, whose degrees of freedom will be 2265.413. P-value equals -3.422. P-value equals to Okay, this 0.001 is for two-tailed test. Two-tailed, and ours is not two-tailed, so we're going to divide by 2, which is 0.0005. This is for one-tailed test. Alpha is still 5%. Alpha is still, see, my bad. So alpha is still 0.05. So our P is apparently less than alpha, right? Okay. So p-value is smaller than alpha, therefore we reject null hypothesis and accept alternative hypothesis. Reject null and accept alternative. Summarize our conclusion. Okay, we have rejected null. That means there is sufficient evidence to claim at alpha equals to 0.05 that the meaning of alternative, right? The meaning of alternative, which is, let's see, what's our meaning of alternative? Mu1 is less than mu2, which means people in the South have less years of education than people not in South on average, right? People not in the South. Okay. And make sure you put a p-value there. P-value is 0.0005. Okay, so that finishes our question for 2 sample t-test of comparing people from South to not South. And we first did recoding to put the regions into two variables, which variables South or not. One is in South, one is not in South. And we're comparing these two groups by using the 2 sample t-test. And I want to emphasize, when you're doing such problems, make sure in your alternative hypothesis, you first will make sure the right sign is being used. Less years, so it'd be less than, right? Mu1 is less than mu2. And also make sure when you go to the grouping, the option of grouping, make sure the value matches your group. Okay, so 1 means it's in South and 0 means not in South. Okay, you can also double check your output, okay, in South and not in South. Those are listed in those 2 variables. Okay, so that finishes our session 5, and you will have similar question to do for your assignment. Your assignment will be again based on people in South or not in South. You're comparing the two means. One is about children age kid born, okay, and the other one is about number of children. Okay, so that's all. Thank you.